Welcome to Choose Your Own Adventure, the dignified pursuit of a developer platform. So glad you're here, y'all. Meet Hero. Hero is application source code on a developer's laptop. Hero longs to be a real application running in production, serving end users, and we've been helping Hero along their way. So we've helped Hero evaluate hundreds of CNCF projects, choose which ones to use, integrate them with one another so Hero can live their dream. I'm Whitney. This guy in a skirt is Viktor. And together, I know, I'm messing with you, Chris. Together we host a show called You Choose. So it's a streaming show on Viktor's DevOps Toolkit YouTube channel, and each episode represents a system design choice. So for each system design choice, we gather all the relevant CNCF technology that can do that thing. We invite a maintainer on from each technology, and that maintainer gets only 5 minutes to present about what their technology does, because we just want an overview. Then after that's done, we put it to a vote, and the community chooses which technology we implement in our ongoing demo. So far in the show, what we've already chosen is, here we go, build packs for container images, Harbor for a registry, Carvel for application configuration, Cert Manager for certificates, Crossplane to declaratively define a database as a Kubernetes API, and then we have a schema hero for a schema for that database, DevSpace for developing on Kubernetes, Argo CD for GitOps, we have Contour for Ingress, KubeArmor for runtime security, External Secrets Operator for secrets, we have Cilium for network policy, we have a KubeScape for Kubernetes scanning, we have Notary Project for signing, we have Spiffy and Spire for workload identity, Keycloak for authentication, OpenFGA for authorization, we have Headlamp for Kubernetes API, we have Thanos and Prometheus for collecting and scaling metrics, OpenTelemetry and Jaeger for tracing, Istio for service mesh, and OpenCost for cost management. Oh my God, this is too much. How do we do this, y'all? What have we done to ourselves? So that's why platform engineering has gotten so popular. So an internal developer platform is a set of integrated capabilities that are available to developers for them to use in their day-to-day work. So there are 3 types of people involved in making an internal developer platform. This is an overgeneralization, but it's a good mental model. We have experts. Experts know about one thing, and they know that thing really, really well. And that's great. That's what they do. We love them. We also have our developers. Our developers just want to use those things without understanding all the details about how they work. What they know well is their application. And so as platform engineers, we sit in between the two, and we help the developers get what they need from the experts in a self-service way. So the developers ask for their thing without any humans involved, they get the thing, and then that thing is naturally compliant and it's secure. And that's our platform. We have about 32 minutes left, so let's build one live here today. So we need your help, though, because we're going to go through some system design choices, choose which ones to use, and Viktor's going to build a live demo as we go. Maybe. He's going to try. We're going to use one for API management. We're going to go through a technology for policy. We're going to talk about technologies for one-time tasks. And we're going to add a technology that adds a GUI, a graphical user interface to our platform. And then we'll live happily ever after. So here we go. Let's talk about APIs and state management. The technologies we're going to evaluate are Crossplane and Kubevela. But first, let's talk about what it even means. Why do we have API management? But we're going to even take a step back from that and say, we should build our platform with Kubernetes APIs. So why do we want Kubernetes as part of our platform? Well, number one, Kubernetes is an industry standard. I think since we're all at KubeCon, I don't have to convince all y'all in this room. And then I'm Texan, if you can't tell from my y'alls. So it's industry standard. It also, we're going to take advantage of that Kubernetes synchronization loop so we can use Kubernetes resources to declaratively define states, and then it's going to make that state an actual state. But here's the thing. We're going to use Kubernetes to manage states even if the thing isn't in Kubernetes. So just because we're using Kubernetes as our platform doesn't mean all the platform capabilities have to run as Kubernetes, in Kubernetes. And then finally, the third reason is that we can use everything in the Kubernetes ecosystem. So our developers say, hey, we want a cluster. So we need to build a Kubernetes API. The first thing as platform engineers, we're going to talk to our infrastructure expert who's already forgotten more about clusters than we will ever know. We're going to leverage that knowledge, work together with her, and then make a Kubernetes API that the developers can use to provision their Kubernetes cluster. And we're going to do that with a tool like Crossplane or Cluster API. So our developers say, hey, I want a cluster. In this case, they're applying a manifest to get that cluster. And then our tool, like a Cluster API or a Crossplane, will take that desired state and then actually make, say, a GCP cluster that's running in the cloud completely outside of our Kubernetes management cluster. So why does it need to be APIs, though? Like, we understand why Kubernetes, but why APIs? APIs, you can wrap APIs in any interface. So if you have an API, here's a great example. We have hyperscalers. So if you have Google Cloud, for example, if you want to consume Google Cloud resources, you could do that through the G-Cloud CLI. You could do that through their web console. You could do it through Terraform modules. But all of that is going to the Google Cloud API. And we want to have the same thing as our platform. APIs, and then we can wrap them in interfaces to bring those capabilities where our developers are. And then the other reason is we can use those APIs as building blocks. So we can make one for Kubernetes clusters, make one for database, make one to run our actual application. And then we can actually put those all together and integrate them and offer all of that. We could offer a cloud development environment with the application pre-installed, already connected to a database behind a single API to our developers. So finally, the technology. Crossplane, with Crossplane, you can take any API on the planet, inside and outside Kubernetes, a SaaS, anything, pull it into Kubernetes and manage it as a Kubernetes API. So you have that synchronization loop. You can also compose lots of different resources and integrate them with each other, and you can offer a simplified interface to your developers. Now, with all of that power comes a lot of complexity. So the drawback of Crossplane is it's complex and it can be difficult to learn and use. On the other hand, we have KubeVela. Now, KubeVela is a focused tool. It is meant to be for applications. So it gives you Kubernetes abstractions so that you can define and manage your application within Kubernetes. So you have tools like an application that has components and that has traits and a lot of community support. So it's a focused tool just for making an API around applications. And finally, let's vote. Which one would you like to see Viktor demo? Oh, it's
trying to catch up, huh? Shall we call it a day?
We have 187. The votes are still jumping.
Okay, Crossplane it is.
Crossplane it is. Let me switch okay.
Okay, so let me just do few silly things that I need for the later, just to know what I'm doing. Ignore, don't look what I'm doing. Cool. Okay, so we need a repository, we need a database for an application, we need an application, right? I'm going to try to go fast. Repository part, I already did that in advance. The rest will be live. And I will show you to you. GitHub claim. GitHub claim of what's the name? CNCF demo up, I think.
Oh no, Viktor.
There we go, right? So this is a claim that created a repository with everything I need for the application. You can see there, you can read the files, right? Created the repository, some files, pull requests, and so on and so forth. So I cloned that repository, CNCF demo, there we go, I'm inside. I have a source code of my application. This is a very, very complex Go application written in 20 lines. And now first I want a database, right? How I'm going to get a database? I can write YAML, but I'm not going to do that. I'm going to copy the file that I prepared in advance. I will show you what that file is. I'm going to put it in silly demo db password .yaml. And I'm going to copy another file. I'll show you what it is, so no worries about that. This one is going to be called like this. Cool. And I'm going to apply those two files. And then while it's running, you will see what's happening and what's not happening and so on and so forth. So I want a production apply file name. Where did I put it? Apps, password, cool. I'm going to do this. This is a database. Now while it's running, let me briefly show you what happened really. Apps silly demo database. I have an interface I created called SQL claim. This is how the developers in my organization are requesting databases. They have no idea about subnets, VPCs, whatsoever not, right? This is a custom-made API. And it has some parameters. This is the version I want. I want small database because nobody knows AWS sizes. I want it in this region, and I want 2 databases inside of that server, right? And as a result of all that, beta trace, SQL claim, no, namespace, production, SQL claim. There we go. What's the name of the SQL claim? How did I call it? I forgot. Okay, let's do it like this. Get managed. Eventually, we'll see what's happening, right? What you will see in a second is that you will see all the AWS resources that were created when I created that database. And since do I have time? I have no time. I'm going to carry on. Okay, now let's talk about applications, right? I'm going to, what am I going to do? Oh, there we go. This is my database, right? That from those 10 lists of YAMLs that were created, I got VPC, I got subnets, I got security groups, I got everything that I need as a developer, right? From that custom API. Now let's talk about the application itself. I'm going to copy this crossplane app YAML. I'm going to copy it to apps as well, and I'm going to call it silly demo YAML. Cool. I'm going to apply it. Namespace, space, production, apply, file name is apps, silly demo, YAML, cool. While I'm applying, I'm going to show you what happened, what did I have. Again, this is a customized interface for applications. Developer imagine says, I want an application. I don't know whether I have to have deployment services, ingresses, and CST or network. I'm just specifying that I want it in production. This is my image. This is my tag, and so on and so forth, right? And the result of all that is that I should get a new PR created in my repository. Still not. Okay, that will take a bit. Let's take a look at what I got in production. CTL, namespace, production, get all, and ingresses. Still not running. Still not running. What did I do wrong? Come on. Okay, my demo is failing from the first attempt. Description up, silly demo. Come on. Silly demo. Let's see. Namespace. KubeCon namespace doesn't exist. How? Description. Describe. Is nobody paying attention? Up. Okay, branch CR, return branch CR annotation, to distinguish them. Should be fine by now. Let's see. Get ups. Get all ingresses. Still nothing. Last attempt. Branch silly demo, branch, set different metadata name. Let me see. Code. This is the last attempt, I promise. Apps, silly demo. What did I do wrong? Silly demo apps. Looks okay. Ingress class name, DB secret repository, enable CF. I'll let Whitney speak and then I'll think about it. I'll get to it, I promise.
All right, this is Exciting. Okay,
Very.
here we go. So next up is admission controller policy. We're going to talk about validating admission policy versus Kyverno. So our developers, now they can make themselves a cluster in a self-service way. That's amazing. What if they accidentally, with mistakes or malice, ask for a cluster with 300 nodes? What's going to happen? So we need to put policy in place so that this sort of thing can't happen. So if we're using validating admission policy, which is built into Kubernetes, we can put rules in the Kube API server so that the Kubernetes API server, maybe it's only allowed up to 5 nodes. It's going to return no, and then it's going to send that back to the developer. Or if we're using Kyverno and not validating admission policy, then it goes to Kube API server. Kube API server is configured with a webhook to send that to Kyverno. Kyverno's like, oh, hell no. And then it goes back to the developer and like, sorry, you can't make a 300 node cluster. So that's in our use case, but also you could use policy for lots of other stuff. So to prevent bloated resources, you can use it to stop outdated dependencies. You can use it to make sure that our apps don't pull from untrusted container image registries, that sort of thing. And that's really just the tip of the iceberg. The two technologies versus each other. Validating admission policy is relatively new in Kubernetes, and it uses CEL, which is a common expression language, which is a relatively lightweight way to be able to define what is and is not allowed in your cluster. It also, at this time, only does validation, hence the name, although they are working on a mutating one. So Kyverno is a more mature technology that's been around for a much longer time. It does work with the CEL language that validating admission policy does, but it also has Kyverno JSON query language, which is meant to look and feel like YAML, and that's what it's been using for a long time. It has huge community support. It does validation, of course. It also does mutation. You can do resource generation. It also does resource cleanup. So it's really a much more mature technology. And what really the best way to go is to use validating admission policy until you run up against a use case where you need something more full-fledged and then migrate to Kyverno, and Kyverno makes that really easy. So those are our technologies, and now it's time to vote.
Which one do you want me to fail next?
Ooh, it's a close one.
Okay, one more vote.
Give it a little time.
Okay, 3, 2, 1, Kyverno. Okay, let's do it. I'm going to undo what I did before, and we are going to start over. I'm going to delete the application, delete, and I'm going to push stuff I changed so far. Git add, git commit something, and git push. Cool. Okay, now let's talk about, go back and talk about, what did they choose?
Kyverno.
Kyverno, okay, yeah. Kyverno, right. So I prepared a few policies for you here. Cat policies, Kyverno, IDP, crossplane are we using today? Yes, okay. So here's a policy that we will apply that will be very, very simple, right? It's a cluster level policy. It applies to wherever, whatever. It will apply only to something called upclaim. That's the interface I showed you earlier that allows developers to create applications with everything required for the application. It will be enforced only if somebody tries to create or update. And the rules are, you have to have the scaling field set. That field needs to have enabled subfield. An enabled field needs to be true, right? And this is the text that people will see if they mess it up. And the same thing again, but says, you know what? The scaling needs to have the field min set to greater than 1, right? So you need to enable scaling, and you need to, enable scaling, and it needs to have at least 2 replicas of an application. So far, so good, right? Easy. So let me apply this. Kube control, kube control, apply file name policies. Cool. Okay. Now, let's try again to apply the application that almost worked before, right? Now, this doesn't exist. Okay, yeah, CNCF demo up, and this. Okay, now this time when developer tries to apply application, there is this message, hey, it must be set to true. You have to have the minimum number of replicas set to 2 or greater value, right? Cool. Then the developer does something like this, just using Visual Studio Code, CNCF demo up, apps, silly demo. I will go, and what was the first rule that I said? Scaling. I need to write scaling, and I. Enabled, true, if I remember correctly, right? Now, if I apply the application again, it still complains, but there are less complaints. Now you did the right thing with scaling. You need to put the minimum number of replicas to something else. Let's modify the application. Min, I don't know, 4. Right? Apply. And this would work the same whether it's from Argo CD, Flux, directly, from Backstage, whatever you want, right? Now, people cannot mess it up. And you don't have to watch over their shoulders and spy on them with webcams and all the other things that you're doing, if you're a bank. Go, continue. This time works. 1 out of 1 works.
So now let's talk about one-time task. We're going to talk about Argo workflows and Tecton. So basically, we helped our developers create resources and manage states. But what about those things that developers need to do only one time? How can the platform help with that? So we're talking about things like testing application code, building application images, pushing that image to a registry, updating configuration, testing that new configuration, and then adding it to a GitHub repository or Git repository, which altogether is often called a pipeline. How can our platform help with pipelines? So there are a couple of ways. The first way is our developers need one, and we just give them a template. They can take that template, they can modify it how they want, and it already has our company's best policies and security practices baked in. And then they go run it wherever they run pipelines, because that's already been figured out at your organization, and that's all the platform worries about. Or we can take that a step further, and then we can give them a place to, we can manage the tool that's going to actually run the pipeline, and we can give them the compute to run that pipeline. And so if in that case, we have our Kubernetes management cluster here. When our developers want to make their pipeline, first they have a pipeline definition that we apply to the cluster, and then nothing happens because a pipeline needs to be triggered. And so that can be triggered by a cron job maybe, or most likely by pushing application code. And now our pipeline runs, and then when it's finished running, it's not using any resources. And those are pipelines. Now Tecton is made for this use case I'm describing, where one thing leads to one other thing, leads to one other thing, leads to one other thing. And it can do more advanced use cases, but it's pretty straightforward and designed for that CI use case specifically. Argo Workflows is designed for more advanced, like AI, ML kind of workflows, where it's directed acyclic graphs, where one thing might lead to several other things, each of those might lead to several other things, where your workflow, instead of being called a pipeline, it's called a workflow, and it can get much more complex. It also offers things like loops and conditionals. Now, technically, Tecton does that too, but Argo Workflows is designed for this use case, and Tecton's designed for the more simple use case. And as such, Tecton is easier to get started and use at first, and Workflows is more complicated to use and understand. And with that, which one do we want to see Viktor demo?
Which CNCF projects do you want me to demo of those two?
Yes. Our stuff is limited in scope to CNCF.
Count it.
I think
3, 2, 1.
Argo Workflows.
Argo Workflows. Okay. So let me first go back to the repo and just push if I have anything to be pushed. Add, commit, push. Cool. Now, going back, I prepared the workflow over here, Argo, YAML. This is a A simple one for being Argo workflows. The shortest workflow I could come up with. You chose it, so don't complain. Few parameters, right? This is the repo I want to build from registry, stuff like that. I'm going to check out the code. I'm going to generate the tag. I'm going to build an image using Canico. I'm going to run some unit tests. And I'm going to execute what I call GitOps here. And I'm going to push changes back to Git. Now, each of those is a separate template. This one generates the tag, and so on and so forth. The git push, no, not the git push, but wherever it was, somewhere, I had the one that actually basically, it's somewhere that it modifies ultimately, builds an image, pushes this to registry, modifies my YAML file, pushes changes to Git, and then Argo CD or Flux or whatever you're using can pick it up. So now, in a real-world situation, you would trigger it from GitHub, from GitLab, whatever you're using. In a slightly less real-world situation, you will go through a couple of hours of pain not understanding how to do it. But once you do, that's how it should work. Now, I will skip that part, mostly because I don't have time. And I'm just going to run it by saying submit. This is the same as if it was triggered from GitHub. Submit something to the namespace Argo. And I want that something I'm submitting is Argo YAML, and I think that this sounds correct. And if I watch for changes, you will see now running all the tasks, checking out the code, generating the tag, building, pushing image, making changes to the repo, to the Git repo with the manifest, letting Argo CD synchronize, run some tests, and so on and so forth. Now, this will take a couple of minutes, which we don't have, so I will let Whitney, while this is running in the background, go to the last one.
All right.
Okay, precisely 3 minutes.
Oh, I think...
Including my demo. No.
We have 8 minutes.
8 minutes. Okay.
So
that is fine. Talk slowly.
So
how do you rush?
We've managed we can do pipelines. We basically have a platform built, and now we're going to add a graphical user interface, or a GUI. And we're going to evaluate Backstage and Port for this one. So here's our platform that we built. We have API. It's beautiful. It's so easy to use. We understand it completely. It's amazing. But what happens as it scales and we build lots of APIs and then lots of instances of our resources get created? It can get very complex and very hard to manage and understand very quickly. And so our developers, they can be confused about what's available to them or what they've already provisioned. Our platform engineers, especially across many teams that they're probably servicing, they have a difficult time understanding what's already been provisioned. And so that's where a GUI can be very helpful. So with a GUI, it's a graphical user interface. Our developers can see in a graphical way what's available to them. They can get education around how to use that thing or what options are available for them to change. They can see a big picture of what they've already provisioned. And they also can usually provision stuff through the GUI too. So our platform engineers also have a single pane of glass, as they call, view of what's happening. Now, this is happening from a read-only view from the Kube API. So a GUI is a total wonderful thing to have and absolutely helps your job as a platform engineer, but it's actually not necessary part of your platform. You can have a platform without a GUI. You could understand your Kubernetes resources with the CLI like Viktor just did. So here we are. We have all this complexity, and our graphical user interface is going to help. Now, first up, we have Backstage. Backstage is actually a very popular CNCF project. I believe it's the second most contributed to project behind Kubernetes itself. So it is not a portal itself, not a graphical user interface. It's more of a framework for how you build your own graphical user interface. And there are a lot of plugins already available since it's so popular. But if you want plugins that don't already exist in Backstage, you need to write them yourself, and you need to do that with TypeScript. So it can be complex to get started and use Backstage, although the tremendous community support really helps you with that problem. And then on the other hand, we have Port. Port is a commercial solution. They offer a low-code, no-code approach to make your GUI. and it's much easier to get started and use. And that's it. What would you like to vote for?
None. Cool. Okay.
Excellent. I think we have a winner, Viktor.
You have the winner?
Let's bring it home.
We have the winner. We have no time. Cool. So while that was happening in the background, I already set up Backstage, and Backstage should have discovered the stuff that I did. There we go. That's one of them, right? So basically, this is probably, if you use Backstage, this is probably very different from the Backstage you're using. I'm not defining Backstage component YAML file and none of those things. It's completely dynamic. It goes to my cluster, figures out what I have there, and does three things. One is to figure out what I have and show me. Okay, okay, so you have something called CNCF demo app. Cool. What is it? It's crossplane something. Cool. What are the resources that it created? Those. Cool. What is the graph? Because people like boxes and arrows. This is what happened when I created the application, right? By the way, that's the application that didn't work before. I don't know why it works now. It's fine. Second thing it does, and this is the beauty of Kubernetes having discoverable schema, right? I haven't configured and told Backstage what I want to do and how to what to do. But it did go back to Kubernetes and say, give me schemas of the stuff that can be done in this Kubernetes cluster, right? And if I click create, you can see that auto-detected and generated forms for the same stuff that I was doing before, right? Without me telling it. There is a way to create SQLs, databases, applications, and GitHub repositories, right? Let's say I want a database. Cool. Choose. Auto-generates fields, some generic fields like name, namespace, owner, always admin. You click next. Those are all the parameters that are defined in that Kubernetes resource, just auto-detects. Now, if I would click next, at the end of the day, you would think it's going to apply to the cluster, but that's not what it's going to do. It is in read-only mode. It gets what it needs from the cluster, doesn't write anything to the cluster. If I would click next, it would push it to Git, and that would either update or modify or create a new file, depending on whether that something exists or doesn't. Argo CD would pick it up, it would synchronize it to the cluster, and then we would be living happily ever after. That's it.
That's it.
By the way, let me just quickly check whether whether the application is actually really running, or it's not. But Backstage think it is, so it's fine. Your developers will be happy, living in, being oblivious.
We put the last slide on, please.
Last slide, yes.
Thank you so much for coming to our talk. Will you make it?
I don't know, where is this the button?
Thank you. If you want to see our YouTube show, that's the QR code is. And also, we have a lot of You Choose stickers up here on the stage. Or if you talk to one of us, we have stickers for you.
And lesson learned, if you go to KubeCon and you go to a party or a bar at night and you meet a Scottish person, don't discuss anything that you will regret next year.
Thank you. We did it.
Yeah.